impression of being a swarm of butterflies. By mimicking the real ones, it may be suggesting that there is no perching room for others. And in the detail of their leaves, you can see something even more surprising. This kind of passion flower has a special way of dissuading female butterflies from laying eggs on its leaves. It imitates eggs with these little yellow spots, so that female butterflies will think that these leaves are already taken, as you might say. And this different species of passion flower does the same thing, but imitates eggs in a different way, with tiny little growths at the base of the leaf. The passion flower's tactics illustrate some of the complex ways by which plants dissuade animals from eating them. But some wet zone species have turned the tables. This bud will soon become a leaf. It's no ordinary leaf. It has a special, altogether more sinister purpose. This is Nepenthes, the pitcher plant. It grows in nutrient-poor soils, so has to find nitrogen and minerals in another way. The leaf, just like a flower, attracts insects with a reward. The pitcher is coloured and scented to appeal to flies looking for a meal of rotting flesh. The visitors are rewarded with a greasy substance on the underside of the pitcher's lid. But the plant wants something in return. Not pollen, but a meal. The lip of the pitcher is covered in tiny, slippery ridges. Wax lubricates the surface further. It's extremely difficult to hold on, even for a fly. Once inside, there's no escape. The leaf holds a pool of digestive liquid. This contains microscopic elastic filaments which give it the properties of quicksand. The more the insect struggles, the deeper it sinks. Enzymes begin to dissolve the victim's body while it's still alive. Some pitchers aren't content with just insects. This one eats mice. The mice come along, perhaps attracted by the sweet nectar on the lip. They fall in, they can't get a purchase to get out, they drown, and eventually the enzymes in the pitcher's fluid dissolves the body so that eventually there's nothing left but a bit of fur and bones. This pitcher is called Nepenthes lowii. It lives on the forested slopes of Borneo's mountains. And it's perhaps the most extraordinary pitcher of them all. The evidence is that it too attracts small mammals. It secretes a sort of nectar from the underside of the lid there, and that attracts little tree shrews. This engaging little animal is Tupaia montana, the mountain tree shrew. It feeds on fruit and any insects it can find. It also visits pitcher plants. Until recently, what happens next was a mystery. This footage seems to show that the animal has found a way of evading the slippery death trap. What is more, it's feeding on the underside of the pitcher's lid. This pitcher doesn't get its nutriment from the bodies of dead animals. It's got another way of sustaining itself. The tree shrews come to lick it, and when they do, their rear end is directly over the pitcher so that their droppings fall into it. And it's that that provides this plant with its nourishment. It's even been suggested that that nectar contains a laxative to persuade the tree shrew to do just that. The stability of the rainforest environment over time has allowed the co-evolution of animals and plants to develop to an unrivaled degree of complexity. But with complexity comes fragility. Each and every species has its own place in the complex working of the rainforest. In recent years, Kew's unique position as a living laboratory of the wet zone has become more important than ever. These days, Kew's role extends far beyond these 300 acres. And here people are working to rescue extremely rare plants from total extinction. The danger of losing a single species is taken very seriously indeed. Here in the water lily room, experts face a desperate scramble to save one species from oblivion. Nestling amongst the giant water lily pads is the tiny Nymphea thermarum, the Rwandan water lily, the smallest and rarest water lily in the world. Extinct in the wild, these precious few individuals are some of the last remaining specimens. These photographs show its only known native habitat as it was over 20 years ago, a hot spring in Rwanda. It was destroyed just recently when locals redirected its waters to supply a laundry. A single specimen was brought back to Europe, but the species remained on the brink. Its seeds would germinate, but the seedlings always died. Then some seeds were given to this man at Kew, Carlos Magdalena. Known in Spain as the plant messiah, Carlos is famous for his great skill in rescuing endangered species. But even Carlos nearly met his match with this tiny plant.
I tested many different seedlings, nothing seemed to work.
Well, that meant that the species was about to disappear forever.
Exactly, and that was very worrying for me. So I started becoming a little bit obsessed with it. Yes, I mean, it's just a bit distressing, isn't it? To know that something that you can do or not to make a difference to a species.
Carlos didn't give up. He had one more unlikely idea. He tried growing the water lily out of water.
If you think about it, growing a water lily out of the water is something as crazy as trying to grow a cacti floating in a pond. So it was the last unlikely thing that logically you will do. And then that is the result.
Carlos's inspired idea was to make use of this plant's strange ecological quirk. Nearly all other water lilies only grow in deep water, but the Rwandan spring was very shallow, little more than damp mud. And so by growing it in pots above the water, Carlos replicated its natural habitat. Within a few short weeks, there were 50 specimens, all set to flower. So this is a crucial moment, because if this works, and it's clearly going to, you have in fact yourself saved a species.
If I didn't have this crazy idea, the whole species will be gone forever.
That's absolutely charming, beautiful. In an environment with so many species and so many spectacular ones, it might seem odd to spend so much trouble in trying to save just one comparatively inconspicuous one. But the relationships within the rainforest are so complex and so extensive that the loss of just one can have a whole series of unpredictable consequences. The loss of a plant can mean the loss of an insect. The loss of an insect can mean that a bush loses its pollinator. The loss of a bush can mean that a mammal has lost its food plant. Nobody can say exactly when or if such things are going to happen. But to me, preventing it happening in the first place seems to make absolute sense. The story of plants spreads well beyond the wet zone. They have evolved to occupy almost every environment on the planet. They survive in regions of constant change. They thrive in soils that almost never see rain. As we will discover, they do much of their living in ways that go almost entirely undetected by us.